Hi, welcome to an OSLO video. In this video, I'm going to talk about the menus at the top, and then at the end, I will talk a little bit about this configurable button bar here, as well as this status of preferences at the bottom. OSLO has a lot of built-in features, a lot of built-in things that it can do, and the majority of them can be accessed through the menu bar at the top. And the purpose of this video is to give you an idea of where to find things in there. Most of the items that make sense where they are, but there's so much in the program, and some things are, they're kind of in between. Maybe they could be an optimization, maybe they could be an evaluate, for example. So one was chosen. So I'll point out some things like that. So starting off, the file menu has the usual open lens and save lenses and that sort of information. You can actually load a file that has a set of commands and it'll run it. It also has database information, lens database. You can also open databases that you build. You can import lens files from a number of different formats. Of course, with that, always be sure to kind of check both sides of it. It's nice that it has an import feature, but I always double check everything because programs are updated and keeping things in sync is not always guaranteed, and certainly with special surfaces and such, that can be a little bit of a tricky business. You can export lens to different CAD formats, and that of course is real useful when you're laying out your optomechanical design. Then there's these two sections. One allows you to do printing of text windows and saving of text windows. This will apply to the current active text window. And then similar sorts of things with the graphics windows. Graphics windows and text windows are covered in more detail in another video. The next area down here is preferences. So preferences are settings that are used for all files that you would have open in OSLO versus operating conditions, which change depending on which file you have open and how it's set up. So these are program wide. There's a number of different groups of them: graphics, program size, and then this pen sequence one. There's a command here to set preferences. You can show preferences. Now, of course, that's what this bar does at the bottom, but that can show the preference for any preference that you so choose. Restore default preferences just sets them back to the sort of factory settings. So if I go here to preference groups and I go on to graphics, for example, you see it opens a pop-up menu. Some of these commands that you would call under the menu file will open up menus like this. Some will open spreadsheets, some will print information out in the graphics window, some will print it in the text window. So it just depends on what you're doing. And you can see there's a whole set of different options here under these graphics preferences. The last part of the file menu is the history, which says what files were opened the last session that correctly terminated that you had with OSLO, and also you can exit the program here. So relatively standard stuff, but a few things in there, such as the preferences that maybe you wouldn't quite expect to be there, but a lot of file manipulation kinds of stuff. The next is the lens. The lens tends to be about the data that you have for the lens file. So for the OSLO file. So if I go here and I click on my surface data spreadsheet, I have I open up the surface data spreadsheet, and that was shown in an earlier video. Pardon me, I had to cough there for a minute. The next thing down on the lens sheet here is glass catalogs. So glass catalogs, and it's very important to have material databases defined properly. This kinds of things you can do to set up your own preferred glasses, add different glasses in or different materials in that you may be doing design with or analysis with. The coatings, same type of thing, but for coatings. The next set of these are not about manipulating material data properties or the lens data properties like the top part of this. This shows different sets of data. So show surface data opens up one of these menus, and if I just hit OK, you see now it's given me a whole bunch of information about that lens file. And there's a whole bunch of other Ones of these shows tolerance data, optimization, operating conditions, and auxiliary data. The lens drawing will allow you to draw the lens. So if I draw the lens system, pops open an option menu, and then I come here. Some of these quick buttons on the graphics will do a canned set of settings on these, so using the menu can be a little bit more flexible because you can choose to change some of these settings sometimes a little bit more readily, or maybe more directly. If you actually have one of these open though, and I'll show this later, you can actually right click and change this sort of stuff. So it's not completely that you're not completely tied into how a graphics window is going to be updated. You can change it multiple different ways, but it can be nice when you're first running a command to just run it through here. Lens drawing conditions just sets different operating conditions effectively for the lens drawing. The next is optimize. Optimize has paraxial, aberration, then a bunch of ray trace commands, followed by imagery. So real imagery, what are the spot diagrams? What's the wavefront? What would transfer functions be, like the MTF, point spread function, line spread functions, and then energy distribution, such as knife edge kinds of things. So lots of different imagery related parameters there. Polarization is actually here. And then autofocus. Autofocus is a little bit of the odd one out. All the rest of them have been first order, third order, ray trace stuff, imagery, and polarization. And then you get to the bottom, and now autofocus. Well, this is just saying if I'm going to focus my system, there's a number of different ways I could do it. OSLO gives you the ability to do a quick focus based on the current configuration. And what it will do is an autofocus would actually change this last thickness to refocus the system in some sort of way. So it's a little bit of the odd one out, just simply because it actually changes a parameter in here versus just doing some evaluation. So that's why I spent a little bit more time pointing that one out. The next one over is optimize. Optimize is where you will set up different parameters that you will that determine how good is your system, and also will allow you to set variables. There's a number of ways to do this. There's a number of built-in error functions or merit functions, figure of merit, whatever you would like to call it. These error function tables actually open up different field points and ray positions in the pupil, which the ray positions of the pupil is the ray set, and then there's also a spot diagram set for certain things. These just open up spreadsheets that show you what those data sets are in the program right now. Operands does a similar thing, but it does it for what the merit function is, or what the error function is. So if I come here to optimize and I go and generate an error function, and I just go ahead and use the default. Now if I come back to some of these error function tables, for example, the field point set is now no longer empty. It actually has some choices in here, and the operand set has some degree of sampling the system in a way to tell me when I optimize how it's going to work. In terms of this case, I just use the default sort of number, so you can have a deeper look at that to see what it's set up. So that's setting those things up. Now if I wanted to optimize this system now, I wouldn't actually be able to do it yet, because I also have to have some sort of variables set. So when I set the variables, that tells me when I optimize, how is the system being changed to satisfy or to minimize the error. In other words, make the best system that I can. So this one, slider wheel design, is specialty. It allows you to effectively alter a 1 or 2 or some other number. If I want 4, for example, different parameters, and as I shift those around, usually there's some sort of output metric that you're looking at to see how it changes. It can be nice to help you really understand how a system behaves, maybe why it's not working, or maybe some ways how to improve it without using the numerical optimizer. So it's a nice graphical method, but you can get more out of it. So set up the merit function stuff and those different tables. This is the variable sheet, and then there's this slider wheel design. The next set here are iterate, which is the damp least squares optimizer in the program, which is the workers optimization function. Notice right now it's grayed out. if I go ahead and define some variables, let me just vary all the curvatures and thicknesses and airspaces. Let me just do everything here. Now if I come back to here, you can see I would actually be able to optimize this system. And there's different settings for the optimizer. That is not the only optimizer in the program. There's other optimizers, some other local methods, Downhill Simplex and Powell's method. There's also Global Explorer, which is a global search method, and then Adaptive Simulated Annealing, which is a global optimization method. So that's where these are. Makes sense. They're under optimized. Conditions that affect optimization are here, and then there's a number of support routines that can help you set up certain things for optimization, and also just do some analysis that relates oftentimes to some of the optimization. But this is one of the ones that some of the stuff down in here, I'm not completely sure why it was originally put here. Vignetting makes sense because if you have a system that vignettes, in other words, if off-axis bundles are truncated or blocked by either not hitting an optic or hitting a piece of metal that you expect to be mounted there, in those types of cases, you would want to set up the system, set up OSLO to trace rays that make the most sense when you have a vignetted off-axis system. And then there are some other ones in here, and they're all a little bit specialty. So that's what's under optimize. Under tolerance, there's the ability to update your different tolerance data, to do random Monte Carlo analysis, Monte Carlo simulations, and of course to do these other more traditional kind of MTF wavefront tolerancing methods that are in the program, as well as change tables, which is a way to look at a set of defined aberrations that you get when different errors in the system occur, and they're ones that were used when tracing rays was much more difficult. Nowadays, people often will just trace more rays through the system and use things like Monte Carlo analysis to verify if the system works or not. But the change tables were a traditional method for that. So it's got some traditional stuff. It's got some things that help you do sensitivity, inverse sensitivity analysis, and then it has simulations and update tolerance data. So tolerancing is all about, I have my system, and now I'm going to determine when I build it, is it going to work as I expect? Or how do I design what goes on to drawings in terms of tolerances so that it's going to work as I hope or expect? Sources just is ways to set up different kinds of sources in the system so that you don't have every system being like sunlight that fills the pupil uniformly. So there's extended sources, the ability to look at pixelated objects. But the other thing under sources besides these is some of the beam stuff. So this is where the paraxial Gaussian beam, skew, and truncated Gaussian beams are, as well as fiber coupling. So that, of course, makes you think about coupling light into a fiber and what's my coupling efficiency. So that's where this analysis is in the program. And then there's a little bit on partial coherence here as well. So things that relate to a source that's not a white light incoherent source in a sense. Tools is the top part are tools that help you compile custom CCLs or to search through CCL libraries. There's a nice plotting toolkit here, which is really useful when you're going to plot data multiple times or consistently in the program on the fly versus wanting to plot something that maybe there isn't a built-in plot. And what you would want to do then is, you export it to some other program and have a look, or you build a direct link to another program to put the data there and then have it plotted out. So there's a way to do that in OSLO. Also under tools are a couple of just special cases that people included. One was a 2D waveguide, another was some spherical mirror. And then there's some demos, including one that shows aberrations with sliders, bending doublet, bending a triplet, making the lens bend one way or the other and seeing how it works. And so there's some other nice little tools there, but ones you probably are not going to use on an everyday basis. Under window is this is the text, graphics, and editor windows. Now text and graphics, you can have two text windows open, so this allows you to open them and close them and reset, change the titles, update them all at once, and so forth. Graphics, you have the same type of thing on them, and you can also save the file and copy to clipboard on all of these different window. You can also do that from the window and text editor themselves, and check out the other videos that are going to show some of that. Under editor, this is what's used as a text editor in the program. So you can actually write a lens file if you want, type it in that way with SCP commands or something, or you can, or CCL even. Typically it is used for CCL development, where you would write your own little program or routine and then you save it in a certain place and compile it, and off you go to the races. And that is where you compile them here under tools. The choose fonts, arrange icons, etc. These are things to manipulate windows and allow you to make them look a little bit different. Under the help is the OSLO help, which can also be accessed with F1, the tip of the day, and then the typical about OSLO pops up what version you have and other information. So that's it for the menu. See, lots of stuff there. There's a rhyme to the reason, so to speak. There's reasons why different things are placed in different locations, but I wanted to spend some time on a video going through all of those. The last two parts now, I'm going to now talk about these buttons up here. I'm not going to go through all the buttons because there's these nice little tool tips that pop up when you go over them, and also you could just hit them and try it out. Like this, for example, compiles the CCL. This opens the surface data spreadsheet. This would open a new file, save a file, open different text editors and such. And you say, wow, well, there sure are a lot more things on the menu than there are on these buttons. Well, it turns out there's this button here, which not only allows you to manipulate some of the windows with these things up to the up here on the top part, but in the bottom part, let's say I want to look at some optimization tools. Well, if I want some optimization tools, I can actually turn these on. And let me say I'm doing a lot of optimization. I don't even want the standard tools up. I've now changed this bar up here where the standard tools are not actually there, and instead I have these optimization tools. So this is highly configurable, and there's a number of different buttons that you can do for them. So that's pretty good and nice to use if you're using certain functions a lot, and you're more than happy to just click the button and live with the command defaults that it has in there. So that's what this top button bar is about. It's really nice and useful. Down here at the bottom, the last thing I'll talk about is this preference bar setting. So if I double left click on it, so here if I double left click, it gives me the choice to add different preferences that I want to actually see. So output logging, that one's actually off. So these different preferences, if I open another file now, it would stay the same. Those aren't going to change. Those are set based on the program running because they're preferences. And this just is a quick way for me to be able to look right at it and tell what different settings are for those. The other way you actually get to this, by the way, is it's over here somewhere. Where was it? I had found it. Graphics windows, status bar. That's what that status bar was. It was the same thing. So it's here under window, status bar. It's the same as double left clicking here. So it's the preferences status bar. I hope you found this video useful. Thanks for your attention.